So today's lesson is factoring trinomials, guys. This is really 13.2 through 13.4. So those that kind of like just to keep track, what sections are we covering in the book today? Again, I kind of mentioned it already, 13.2, 13.3, 13.4 are technically three different things, but they're all taught the same way. So we're just going to shove them into one lecture. It is a longer lecture, so I apologize. Bear with me. All right, so what are these things that we're going to be factoring? They're called trinomials, so prefix tri meaning what? Three. So if you have a trinomial, it means it has three terms. What is a term? A term is either a number, a variable, or a combination of a number and variable shoved together using multiplication. And then how are they arranged? They are gathered with either a plus or a minus with them, okay? So notice this is a trinomial because x squared, 8x, and 12 are all terms. And then there's pluses that are gathering them together. All right, so how do we do this? The number one thing always is factoring out your greatest common factor. So the first thing you need to do, and I'm bad at it, so call me out because I will forget. Be like, Molly, don't forget. Look and see if there's a number or a variable you can pull out of all three terms first. If so, do what we've been doing, type it in my math lab, pull it down, and then focus on the remaining trinomial. All right, the next part, what it is trying to get you to get a three-termed item, a trinomial, to a four-term item, so you can do factor by grouping, which we did in the last section. So how do they do it? They call it the AC method, rainbow method, whatever you need to call it. So it's for the resulting trinomial, ax squared plus bx plus c, where a is the coefficient of your x squared term, and c is your constant. What we're going to do is we're going to find two numbers whose product is a times c. Product means multiply to be a times c, and whose sum is b. And at first you're like, well, what does that even mean? I think doing it is easier than trying to make sense of those words. So we'll do it here in a second. Once you come up with those two numbers, the whole idea is since the sum equals b, you can actually write b as those two numbers, and you've now taken a three-item thing and turned it to a four-item thing, and you can do factor by grouping and step 4. All right, so the first thing I do, and you don't have to, but we're going to look at this first example. I put a 1 in front, just so I know my a is 1, okay? So that's technically what 13.2 is. Your a is always 1. How do I do it? You can call it the rainbow or call it the AC method. You take your a times c, and you write its product. So what's 1 times 12? 12, okay. So what is our goal going to be? Our goal is to come up with two numbers that multiply to be 12, the product of a times c, but they add up to be that middle number b, 8, okay? Some of us can just go right to it. Some of us are like, I don't know. So what we can do is we can write this chart over here. So it multiplies to 12, but it's going to add to 8, okay? Again, some of us know right now. You do. You know what those two numbers are. But those that don't, there's a systematic way of doing it. So how do I come up with multiples of 12? They're really just factors of 12, right? So what are two numbers that multiply to be 12? I just start with 1. 1 and 12. You guys agree with that? 1 times 12 gives you 12. But what does 1 and 12 add up to? 13. We don't want that, okay? So we're going to move on. What else goes into 12? I just divide my AC by 1, 2, 3, 4 until I get what I need, okay? So what's 12 divided by 2? 2 and 6. What does 2 and 6 add up to? 8, and that's what I want, okay? Say that wasn't the number I wanted, then I would move down to 12 divided by 3. So my two factors are 3 and 4, and that adds to 7, and so forth, okay? So you just keep dividing by 1, 2, 3, 4 until what you get. So what does that mean? It means these are the winning two numbers. What I'm going to do is I'm going to keep my first term, x squared, exactly as is. I'm going to keep my back term, 12, exactly as is. But what I'm going to do is I'm going to rewrite 8x as 2x plus 6x. What is 2x plus 6x? 8x. So I'm not changing anything, right? But I'm drawing it out to make it 4 terms. So write x squared plus 2x plus 6x plus 12. Oopsie, here we go. Guys, this was Wednesday's lecture. How do we do factoring of 4 terms? What do we have to do? What's our first move? No, we're not going to combine. So it's the opposite way. We actually don't want to combine because where do we go? Right to where we were. So what we want 4 terms because that's what we learned, factor by grouping. How do you do factor by grouping? You look at the first 2 terms, right? So we're going to look at these 2 terms and say, well, what do they share in common? go ahead and factor out an x. When you factor out the x, what's going to remain? X plus 2, right? We had 2 x's, we took one away. We had 2x, we took his x away, but there's a plus 2 here. All right, now we're going to look at the back two terms. Remember, whatever's left, we want it to match x plus 2. So what can we factor out of 6x plus 12? A 6, but not only a 6, but a positive 6, and you may have said that. So I always want that sign in front. We don't need to change our sign at all, right? So 6 divided by 6 is 1. I don't need to put a 1 there because my x is my placeholder. And then 6 divided by 2, or excuse me, 12 divided by 6 is 2. Yes, that's what we wanted. Remember, celebrate the small things, because what do you notice they both have in common? The x plus 2. So we're going to factor that out one last time. When I factor out x plus 2, what's my remaining binomial going to be? X plus 6. You got it. Guys, what we just did was we just unfoiled, right? We're used to foiling. X times x, you get x squared. X times 6, you get 6x. 2 times x, you get 2x. Combine like terms, you get 8x there, right? And then 2 times 6 is 12. We just unfoiled, aka factoring. This is probably the best scenario. Why? Because all the signs were positive, so we knew all of our numbers were positive. There's no tricks on one's negative, one's positive. It's the best scenario. What's the next best scenario? This guy over here. When our AC is positive and the B is negative, we can handle it almost as easily as we could have handled that guy. So again, my A is 1, so I'm going to put a 1 right there. And then what's A times C, my rainbow, 1 times 6 ends up being 6. So what I want to do is I want to think of two numbers that multiply to be a positive 6, but they add up to be a negative 5. So I'll write that over here. So they multiply to 6, but they add to 5. So again, I start with 1 and 6, but let me ask you, what is 1 and 6? That's not going to add up to a negative. I want a negative 5 there, and I didn't write it. So will you guys make sure you put a negative in there? That's my fault. Realize that when we multiply to be a positive number, but we need to add up to be a negative number, what do we know about both of our factors? Both of our factors must be what? Negative, right? So how do you get a positive number when multiplying? When both are positive, they end up being positive, right? But what happens when you add two positive numbers? You get a positive, right? Or you have a negative times a negative. What's that multiply to be? A positive. But what's a negative plus a negative add up to is a negative. So what I do is I start with my numbers 1 and 6, but I know that they both need to be negative if we want to even consider adding up to a negative number. Is that the combination I want, though? Negative 1 plus negative 6, what's that get me to? Negative what? 7. I don't want it. So what's the next thing I do? I take 6 divided by 2. 6 divided by 2 is 3, so I get 2 and 3. But what do I know about both those signs? They both must be negative. Because negative 2 times negative 3 will multiply to be that positive 6. But what do they add up to? Negative 5. That's what I want. Ding, ding, ding. We got our winning guys right here. So what does that mean? It means y squared stays y squared. 6 stays 6. But instead of writing it as negative 5y, I'm going to write it as minus 2y minus 3y. And realize the y goes with them, because we do want them to be like terms, right? It's rewriting them. Instead of combining them, it's rewriting them. So we'll write this as y squared minus 2y minus 3y plus 6. Does that look okay so far? And do you agree if you were to re-add them, like do like terms, you would get back to that negative 5y? Yes. Real quick question. Does it matter whether I write the negative 2 first or the negative 3 first? Does that matter? It doesn't. So throughout this lesson, I will challenge you and say, hey, I wrote mine like this. You flip-flop the order. Guess what? You'll get the same answer as me in the end, okay? All right, so factor by grouping, we now have 4 terms. So let's look at the first 2 terms. What do they share? A y. Let's factor him out. We had 2 y's. We took 1 away, so 1 remains. Negative 2y had a y. We didn't touch the negative 2, but we took away his only y. Is that okay? Now look at this back part. We want y minus 2 to remain. So what number do we need to factor out? A negative 3. You knew we needed to change the sign. Say you don't notice that at first when you factor out a positive 3, you'll be left with a negative y plus 2, and you're like, oh, they almost match, but not quite. That's your signal. Oh, go back and do a negative 3 instead. So we're going to factor out, and I think that's why MyMathLab pushes you towards that in the first section, 13.1. I think that's why they force that negative idea at you, because most of the time it needs to be a negative that's factored out. All right. So a negative divided by a negative will give us a positive y, but then a positive 6 divided by a negative 3 will give us that negative 2. Yay! Celebrate the small things. That's what we wanted to happen. So our last little step, guys, is now that we have that common factor that they share, pull that common factor, y minus 2, to the front, and what will remain? Y minus 3. Is that okay? Don't believe me? Double check. Y times y is y squared, and go ahead and FOIL, and everything should work. Okay? So this last step is, he's one ugly term, and he's one ugly term, because that's multiplication right there. And that's multiplication right here. They both share y minus 2, so we pull them all the way out in front, and when we did that, the y was left here, and the negative 3 was left there, and we're good to go. All right, so this is like best case scenario. This is like, hey, not too bad, runner up. These are where I think it gets tricky, and I'm not telling you that to scare you. I'm telling you that to be just extra careful and extra cautious. Whenever your AC is negative, how do you multiply to be a negative? One's positive, one's negative, but the factors of which one is can change, all right? So keep in mind your B term, that middle term of negative 5, and that middle term of positive 10, he wins. He's the bigger factor. He takes on the sign of the bigger factor, okay? And I'll try to point that out every time we do it. All right, so you look at this, you're like, oh, I can go right to it. It's the exact same thing. I'm going to just switch up a negative. It's actually not. So let's look at that. So your A is 1. So you do A times C, and you get negative 6. So it's kind of the same setup as here. We want to multiply, but this time instead of 6, we're going to multiply to negative 6. I'm going to go over here, multiply to negative 6, and we want to add to a negative 5. All right, I do the same thing, 1 and 6, 2 and 3, and I do that without thinking of signs. Is everybody okay if we just write those down real quick, leaving room in case we need to add negatives? So I'll do 1 and 6 multiply to be 6, 2 and 3 multiply to be 6. That's the only factors of 6. But then I'm going to go back and take, okay, I didn't want to multiply to be a positive 6. I wanted to multiply to be a negative 6. So one of those factors is negative, either the 1 or the 6, or the 2 and the 3. How do you think you decide? The sign of the B is the bigger factor always. He wins. He pulls you down if he's negative, right? So what does that mean? It means, in this case, the bigger factor 6 needs to be negative, and the bigger factor of 3 is going to be negative. That's how they make a sum negative, right? The bigger guy pulls you down. If you have more debt than you have profit, you're in the negative. So remember, whenever you have opposite signs, the sign of the bigger factor will match the sign of B, the middle term. When you look at those two things, what do we get? We get negative 5 and negative 1. But what did we want? Negative 5. So this is our combination here. And notice it's not the 2, 3 that we maybe thought it would have been, right? All right. So again, you can write it like I'm going to write, or you can switch up the order. It's totally up to you. I'm going to write this as y squared, and I'm actually going to write it as a 1y. I know that's weird, but I'm doing it. Minus 6y minus 6. And I like to put that 1 there just that way when I pull out that y, I know my placeholder is going to be there. I can represent him. All right, looking at the first two terms, what do those two terms share, guys? A y, is that okay? Let's pull out a y. When I factor out a y from y squared, I'm left with a y. When I factor out of plus 1y, I'm pulling the y, but that 1's the placeholder, like, hey, there was a y here at one point. All right, looking at the back, we want positive y plus a positive 1, so who do we need to pull out? Negative 6, right? You see the 6 for sure, but then realize, hey, I want positive stuff to remain, and right now everything's negative. So let's pull out that negativity, and it'll leave some positive stuff. So negative 6 divided by negative 6 will give you that positive y that you're wanting, and then negative 6 divided by negative 6 will give you that positive 1 that you're wanting. And that's what we wanted, right? So at this point, realize those two terms are pretty ugly, but they both share a factor of that y plus 1. So pull that y plus 1 all the way to the front, and then say who's left in this term, the y, and who's left in that term, the minus 6. So if he matches, so let's pull him all the way to the front. But when I pull him out of this term, he's pulled to the front, I'm just left with the y. And when I pull him out of this back term, he's pulled all the way to the front, what am I just left with? Minus 6. And those are ones that I might double check, just to make sure my negatives are adding up. So the 1 and the negative 6 will definitely multiply to be that negative 6, but the positive 1 and that negative 6 will add up to be that negative 5. Is that okay so far? All right. Last one's actually exactly like it. The only difference is now the B's positive, meaning our bigger factor will be the positive one. That's the only difference, okay? So again, my A is 1. So I'm going to do AC of, what's that going to be, negative 24. Does that look right? So I'm going to multiply to be negative 24, but I want to add to be 10. All right, so again, I don't even worry about my negatives. I just kind of go through 1 and 24, 2 and 12, 3 and 8, whatever, okay? 1 and 24. We'll start, and we'll just do the first couple. Actually, we can go all the way down. It doesn't really matter. Okay. So, if they have lots of, like 36 has tons of factors, maybe just do the first couple, go back, worry about the signs. If that doesn't work out, go and keep doing them. Okay. So what do we know about this? They need to multiply to a negative 24, not a positive 24, meaning one of the factors is going to be negative. How do you know? Well, your B, that positive 10, is going to be the sign of all the bigger factors. So if you're doing it in the order that I am, all these should be positive, and all these smaller factors in front should be the negative ones, all right? So we'll just go through and throw negatives in front of all those. So do you agree? Negative 1 times 24 is a negative 24. And that adds up to a positive number, 23. But is it the positive 10 that I wanted? No. And then you move on. Negative 2 times 12 multiplies to be negative 24, and it adds to be positive 10. So I don't even need to keep going with these. I know that he's my winning factor. And that's how we're going to write the p's in the middle, okay? So p squared will stay p squared. But then this will be negative 2p plus 8p minus 24. Nope, why did I do 8? Don't ask me. I don't know. 12, right? Write 12 there. I was looking at the one right below it. I was like, that doesn't add up to 10. Why is that there? Does that look okay? Double checking. All right, and this one's kind of straightforward. We're not factoring out any negatives or anything. What can we pull out of the first two terms? P. When I do that, I'm left with P minus 2. Does that look okay, guys? Any questions on where that came from? And then on the back half, I want P minus 2 left. What can I factor out of 12 and 24? 12. Usually I use the first number as my goal. Like, I just want a P remaining, so that coefficient of 12 is out of my, it's in my way. Let's pull him out. And if I factor him out, does he leave that 2 in the back half? He does. So we'll do a positive 12, and we'll have P minus 2. And again, celebrate the small things. This ugly term has a P minus 2 in it. This ugly term has a P minus 2 in it. So let's pull it out all the way to the front. And what are we left with? P plus 12. Is that okay? So those are 13.2 when your AC is 1. One little trick I'm going to show you. Do I do this all the time? No, but I like to show it because some people are all at different levels. If your AC is 1, there is a shortcut. Whatever you pick as your winning factor actually ends up being your final answer. Do you see how we pick negative 2 and negative 3? And what do we have left down here? Negative 2, negative 3. Notice here we're picking negative 2 and positive 12. What do we have left down here? Negative 2, positive 12. Why do I not teach it that way? Because here in a second, when your A is something different, it doesn't work out that way. So I always kind of teach it holistically with the same pattern, but when you get further along and you're noticing that, when your A is 1, you'll be fine. But when you get down here and your A is something other than 1, yikes, we have to do factor by grouping. We have to use the AC method. All right, so 3 times 14, oh goodness, this is where we're using our calculator. What's 3 times negative 14? Is it negative 42? Is that what you said? All right, so we're going to multiply to be a negative 42. And we're going to add up to be a positive 19. And this, again, is where I kind of just go through the motions. I don't know 42 great. I mean, I know a couple things, but not a whole lot. So I'm just going to do, 42 and 1. So 1 and 42. What else? 2 and 21. 3 and 14. And I'm going to just do those first 3 initially, okay? But we could go on, 6 and 7, go into 4, you could keep going, but you might not need to. So what I'm going to realize is, I need to be a negative 42, so one of my factors needs to be negative. Which one, though? The smaller one or the bigger one needs to be negative? The smaller one. Why? Because the bigger one's going to wear the sign of the B. In this case, the B is a positive 19. So all these bigger ones are going to match him, and then all these are going to get us to that negative 42. All right, so we do the first one. Negative 1 and 42 gets us to 41. And then negative 2 and 21 gets us to 19 pretty quickly off the bat. So we're kind of fortunate with these notes that we only have to do like 1 or 2 factors. not going to be the case in my math lab, so don't get frustrated, just kind of do systematically. Guys, we have it. That's the only difference, okay? Is now my A was something other than a 1, but we're doing everything the exact same way. So my A still stays a 3x squared. So even though he turned into a 42 or whatever, keep him 3x squared, and then write him as a negative 2x plus 21x minus 14. Is that okay? And now when you do factor by grouping, you may perhaps have something other than just a variable to pull out. In this case we don't. We have 3 and 2. But you might have had 3x squared and 4x, and you might have been able to pull out nothing else, I guess. But if it was 3 and 6, you could have pulled something out. All right, looking at those, the 3 and 2 don't have anything in common, but do you all agree that we can pull out an x? Does that look okay? The 3 didn't get touched, so he's still there. X squared changes to an x. The 2x didn't get touched, but we took away his x, so 3x minus 2. On the back half, I want 3x minus 2 to remain. So this is what it's kind of talking about. Look at that first term. What do you need to pull out of a 21 so that a 3 remains? 7. That's what I kind of use as my goal. So even though I might look at 21 and 14 initially, I'm like, I don't know what they share. Look at hint. 3x is what you're trying to get to. So let's pull out a positive 7. And when you do that, 21 divided by 7 is a 3x, and then negative 14 divided by 7 is that negative 2 that we wanted. Yes, we did it right. Last thing, notice they both have that ugly term of 3x minus 2 that we can factor to the front. But when we do that, x plus 7 is what remains. Notice, there is no shortcut. Nowhere in our final answer do you see the number 21, right? So you have to realize that if you have an A other than 1, we have to do factor by grouping. So that's why us teachers, I don't know if anybody else has taken a 116 course, a lot of times we just say, just do it this way. It'll cover your butt and you don't have to stop and say, when can I do it and when can't I? Every way it will work. All right. One thing where I've been failing you, and it hasn't messed us up since, we should be looking at GCFs every time, right? There's nothing so far, even over here, 5, 23, 12, they don't have anything in common. Can't forget about that, though, okay? So what's 5 times 12? 60. So we have to multiply to be 60 and add to be negative 23. This is one where it's kind of the one of the easier scenarios where both of our factors will match. They'll either be both positive or both negative. In this case, they'll be both negative to add up to that negative 23. So I do 1 and 60, and I know they both need to be negative. That gets me to negative 61. It's not going to be good enough. 2 and 30 multiplies to be 60, but they both have to be negative, so that's negative 32. If we had dyslexia, that might almost look like it. So be careful, because it's easy to want to go that direction. And then 3 and 20 gets us there, and if they're both negative, what's that up to? Negative 23, okay? So there's our winner. So when we rewrite this, the 5w squared stays the same, the 12 stays the same. We're just rewriting the negative 23w with a negative 3w and a negative 20w. So 5w stays the same, negative 3w, negative 20w, and like I said, be a rebel, switch the order. Put the 20 in front and the 3 in the back. You'll get the same answer as me, all right? How I did it, though, I don't have a common factor other than w. If you had the 20 in front, you'd have a 5w that you'd pull out. That's fine. Either way, we're both going to get there. So looking at mine, I'm just going to factor out a w, and that leaves me with a 5w minus 3. And again, just kind of being psychic and knowing I want a 5w there, what do I need to factor out of my negative 20? Not just a 4, but a negative 4, right? And when I factor out that negative 4, negative 20 divided by negative 4 is a 5, the w is still there, 12 divided by negative 4 is negative 3. Yay, that's what I wanted. So factor out that common term of 5w minus 3. Do you guys get w minus 4? If you did it that different direction, you would get w minus 4 as your common factor, and you'd factor that out. So your order at the bottom, w minus 4 times 5w minus 3 would be different. But that's okay, because multiplication is commutative. What's 2 times 3? 6, but what's 3 times 2? 6. So this is technically multiplication at the end. They can be switched order. Are there any questions on the front half? You guys are doing great. All right. So let's go ahead and look at the back. We have 3 more to do. One is like that special product that I was talking about. Actually, no, it's not. I guess we didn't see that. I'll have to tell you. And then one is prime. That does exist. And so if there's one that you just can't get to work, that means it might not work. And so prime just means you can't factor any further. All right. Looking at this top one, not a whole lot's going there. I think the only difference that you might notice with this one is that the variables, we have x squared and y squared, that's fine. When we rewrite the middle term, just make x, y's behind both. Let's see if we can get it done in 5 minutes. So we'll do 3 times negative 15 to get a negative 45. So we're going to multiply to a negative 45, and we're going to add to a negative 4. I'm not worried about my variables at all. They will take care of themselves. All right, so I do 1 and 45. 45 divided by 2 is not an even number, so I move on to 3 and 15, and so forth, okay? So we'll do 1 and 45, 3 and 15. 45 is not divisible by 4, so I'll do 5 and 9. I do about 3, and then I go back and fix my signs. All right. It multiplies to be a negative, so I know one of them needs to be negative, but it has to have the sign of b, and b is negative. So the bigger terms are going to be our negative ones on this go-around. So this will get us to negative 44, negative 12, negative 4. There he is. If for some reason that didn't work, just keep going and you would get there. All right. So how is this different? The only thing that's different, guys, is when you go to write that 5 and that negative 9, don't split it up as an x with one and a y with the other, because then those aren't like terms. Keep whatever your variables in the middle with both of them. So write it as a 5xy and a negative 9xy, and that's the only difference. 3x squared plus a 5xy minus a 9xy minus a 15y squared. And by factor by grouping, all the variables will take care of themselves, believe it or not. Okay? So you'll probably have a number and a variable that you can pull out of like the back half or the front half or something. Looking at these first two, how I wrote it, no numbers can come out, but what do they both share? An x. If you flip-flopped it, you could plot a 3 from your 3 and 9, right? So I'm going to factor out an x. 3 didn't get touched. X squared reduces to 1x. 5 didn't get touched. I took away his x, but who's still behind him? His y. And that's the only difference, is that he has that y hanging out. When I go to the back half, I want a 3x in front. What do I need to factor out of the negative 9xy? A negative 3 and a y. Notice the back half, both of them have y's, and we can factor out a negative 3. So a negative 3y will come out, and that negative divided by a negative will leave us with a positive 3. We didn't touch the x, he's still there. We took away the 1y, so that's gone. And then negative divided by negative will be a positive. 15 divided by 3 is a 5. He had 2 y's, we only took 1 away, so who's still there? The y. So see how we didn't have to finagle anything and make anything work? It all just worked out on its own. So the last chunk is to realize that 3x plus 5y is your common factor. So pull that out in front, 3x plus 5y. But what remains from the first term is an x, and what remains from the second term is a negative 3y. Is that okay? Are there any questions there? You good?